everyone, welcome to this video by Wisdom Mitra, your friend in pursuit of wisdom. In this video, we would be talking about time and work in our Quant series. Wisdom Mitra is a coaching institute that has been started by alumni of IIMs and NITs. Time and work is an important concept and it is repeatedly asked in multiple type of exams, whether it's UPSC, whether it's CAT. Usually, one or two questions are asked from this topic. Let us go quickly and review the kind of questions that are usually asked in this particular segment. To begin with, let us take a simple example. Now it says A can finish a work in 3 days while B can finish it in 6 days. In how many days will they finish the work if they are working together? The idea to solve these kind of questions is you should be considering these durations and convert them in the form of efficiencies. Basically, if a person is able to finish a work in 3 days, that means in a single day, in a single unit of time, that person is able to finish one third of the work, right? And suppose this days is not days, rather it is hours. It means, in 1 hour, that person is going to cover one third of the work. So basically, you know, dividing the number of days that a person takes or number of hours that person takes and making it a reciprocal gives you something called as efficiency. Okay, and those efficiencies can be added or subtracted so as to, in case of negative work, you will subtract it. We'll go to such an example also. They suppose two persons are working together, those efficiencies can be added to find the total work being done in per unit of time. So, you know, let us now go ahead and make an attempt to understand what's the amount of work being done every hour by these two persons working together. Just like one third of the work is being done every hour by A, and one sixth of the work is being done by B every hour, right? Then what is the total amount of work being done by both together? The LCM of the two numbers is 6. 3 2 times, 3 1 times. Oh, sorry, 6 1 times. So this is nothing but 3 by 6. That means every day half of the work is getting done. What does that mean? How many days are they going to take to finish the work together? Together they are going to take 2 days because half of the work is getting done every day. The efficiency is 1 by 2 and the two persons are working together. So the answer for this particular question is 2 days. This was the simple example. Usually exams will not ask this kind of a question. This was more to explain the concept. Let us go further and understand a few more examples. Exactly similar kind of a question. Let us pick it up. So every day 1/20th of work is being done by A and 1/60th of work is being done by B, right? A can finish a work in 20 days while B can do the same in 60 days. How much time will they take to do the work together? Let's take the LCM. LCM is 60 here, 3 times, then this is 1, 4 by 60, 1 by 15, which means every single day 1/15th of work is getting done when they are putting effort together, right? That means the total work will get done in 15 days. This is how you look at these kind of questions. Let us pick up third example. A tub can be filled in 20 minutes. Okay. Whereas there is a leakage and because of which the leakage is emptying the tub in 60 minutes. How much time will it take for the tub to be filled when both this particular tap, which takes 20 minutes to fill it, and this particular leakage, which takes 60 minutes to empty it, are opened? So, say every minute 1 by 20th of tub is getting filled, right? That's the efficiency. As I pointed out, the units, whether it's days, whether it's hours, whether it's minutes, it won't make the difference. So every single minute, 1/20th of the tub is getting filled. And when the leakage is also there, every minute, 1/60th of tub is getting empty. So when both the things are simultaneously open, that means 1/20th of tub is getting filled and 1/60th of tub is getting emptied every single minute. Now, how much time is it going to take to fill the tub? So let us see first how much of the tub is getting filled every single minute. Assume is again 60 to 3 times 6 1 2 by 60, which is 1 by 30. That means that the tub is getting filled to an extent of 1 by 30th part of it, which means the whole tub will take 30 minutes to get filled. Is that clear? So the only difference over here is, since it's a negative work, a leakage, it has to be subtracted. Whereas in the previous questions, we simply added it. I hope this question was clear. Let us go further and understand one more. If 25 machines can finish a work in 36 days, working 10 hours per day, then how many machines are needed to complete the work working 6 hours in 20 days? Here, the concept is same. The way we considered, say, the tub getting filled or the person working, here the machine is working, and the unit of work is being provided in two terms: 36 days and 10 hours. Basically, it's again, say, the number of hours being worked, 36 times 10, and 25 persons or machines are working. The same as some X number of machines working for 20 days, right? And they are working for 6 hours. So basically, the total unit of time, 36 into 10, is now changed to 20 into 6. And the number of machines that were originally used were 25. That might be more now, because you have to finish the work in lesser number of days while working lesser number of hours. So this X is going to be lesser. And this gives us the total work, obviously, right? The efficiency of, so I mean, here, that 1 by X thing, or 1 by M, or 1 by E, the efficiency would be there both the sides, right? So that machine is taking this particular amount of time to finish the work, multiplied by 25 machines, and this is the duration. So this goes, that's not relevant for now. That means X, these two things were multiplying X. So when they go to the other side, they are going to divide X. Right? The 6 times, this is 3 times, 25 into 3 is 75. That means we would be needing 75 machines to perform these tasks. Is that clear? The only difference over here is that the unit of time is being given in both days and hours. That means you have to multiply it to get the total amount of time, Rest is all same what we have seen previously. Let us go further. A can do a work in 9 days. B can do the same work in 18 days. They started the work together. After 3 days, C joined them. Who can complete the same work alone in 3 days? Right. So here the concept is that uh, first you have to understand how much work got completed when the two persons were working together, and then how much value or efficiency is the third person adding. So first let us see A plus B, because that's the initial way in which the work was being done. So efficiency of A is 1 by ninth, that is they finish 1 by ninth amount of work every day, because that person is finishing work in 9 days. The second person's efficiency is 1 by 18, obviously because he or she is going to complete the work in 18 days. So every day that person is completing 1 by 18th of the work. Both are working together. That means their efficiency are supposed to be added. Adding them 3 by 18, which is 1/6. So 1/6 of work is being completed every day. That's what we understand. They're working together for 3 days. So after 3 days, C joins. So now for 3 days they have been working. So this is the amount of work being done in one day, right? In 3 days, how much amount of the work would be done? It would be 3 times 1/6, which is nothing but half. So working for 3 days, they finished half the work, right? And now once the half the work was done, the third person joined them. So the amount of work remaining is 1 minus 1 by 2, which is again half. So basically this is the amount of work that is remaining. Okay, and now let us see what's the total efficiency of the three persons, because all the three have started working together. The efficiency of the two persons A and B put together was 1/6. So, right, and the third person's efficiency is 1/3, 1 by 3, because that person is able to complete the work in 3 days. So both these people combined is 3 by 6, which is again 1 by 2, which means the efficiency of all the three persons put together is half the work every day. And since only half was remaining, this particular work would be done within a single day when all the three are working together. So additional time taken to finish the work when all the three are working together. So first 3 days, A plus B, right? This is the day one, then this is the day two, this is the day three, and all this put together, we saw that half the work got completed. And then on third day, these three people are working together and they are finishing, oh sorry, fourth day, they are finishing half the work. This completed 1/3, this completed 1/3, this completed 1/3. So effectively, it would take 4 days to complete the work all in all, when only two persons are working initial 3 days, and on the fourth day, the third person gets added. These are the kind of questions that are usually asked in the exams, the one that I showed in the previous slide, this one, as well as this one. So these ones should be understood. You should practice them. Let us go a bit further. It says, 35 boys can do a piece of work in 15 days. The work got completed in 25 days. How many boys did turn up? Again, exactly same. So efficiency of boys, let it be like they complete E amount of work every day, for example, and they're like we know 35 boys working for 15 days, and the same boys with the same efficiency, they were able to complete the work in 25 days instead of 15. That means 35 boys did not come, some other number came. So let us see what 5 3 times 5 5 times, right? Efficiency is not relevant as of now. So x is nothing but 35 3 times by 5 7, that means 21. So 21 people were there while working, not 35. And that's the reason the number of days taken are slightly more. Instead of 15 days, it took 25 days. So 21 boys turned up. So this is again yet another type of questions that asked. It's simple, it's easy, and the concept is very, very same. It's the efficiency. Multiply it by the number of days being taken, and that gives you the total amount of work. Some amount of work has been completed. First finish that, right? Subtract it out, and then calculate the remaining one. Let us see one more example, which is again involves both negative as well as combination work. So two taps A and B can fill a tank in 15 hours and 10 hours respectively. Right. That means tap A can fill the tank in 1/15th of hour. Every hour it fills 1/15th of the tank. Tap B fills 1/10 of 1/10 of tub or tub every hour, right? And tap C can empty the full tank in 30 hours. So all the three were opened for first 2 hours. What does that mean? Let us see. So efficiency of A is 1/15th. So 1/15th tank is getting filled every hour by it. Efficiency of B is 1/10th, right? And then tap C empties it, so it is negative efficiency. That is 1/30th of tank is getting emptied every hour by it. All the three were open. That means this is how the function was being done: 115, 110, and 130. Let us see what is this efficiency. LCM is 30. This is equal to, you should not confuse, 2, 3, 1, right? So that means this is like 4 by 30, right? So that means 4 by 30th of tank, that is 2 by 15th of tank, was getting filled every hour, right? When the three taps are operating for 2 hours, that means 4 by 15th, that is 2 into 2 by 15th, tank is filled, right? Now, after this happened, the emptying tap was closed down. So that means 1 4 by 15, how much does it bring? It would bring 11 by 15 basically. So 11 by 15th amount of tank is still to be filled. This got filled, 4 by 15 got filled, right? And 11 by 15th is to be filled. Okay. And for doing that, we have the two taps that are operating at the efficiency of 1 by 15th and 1 by 10th. What's the LCM of 2? 30. 15 two times, 10 three times, 5 by 30 is 1 by 6, right? 5 by 30, 5 ones by 6. Okay, you have to be quick at maths. So 1 by 6th of tank is now getting filled, right? So how much time is it going to take for filling this amount of 11 by 15 amount of tank? It's going to take 11 by 15 divided by 1 by 6th, okay, which is nothing but 11 by 15 into 6, 5 three times, Oh, sorry, 3 5 times and 3 2 times 22 by 5. That means approximately 4 hours and 2 by 5 of it. So basically, this is the total duration that's going to take subsequent to closing the emptying tank to fill the whole tank. It might be slightly confusing, I know that. The only difference over here is that instead of dividing it by 1 by 1 by 6, right, we divided it by 11 by 15 because that was the amount of tank that was empty. Yeah, we are back to the original question that we saw. 3 days, 6 days, how many days does it take? I wanted to show a shortcut and let us go back to the question to see that shortcut. If you remember, this is how we did it. And for this kind of simple questions, the other way in which you usually solve is 3 into 6 by 3 plus 6, which is nothing but 1 by x, 1 by y. Then what's the total efficiency? If it's like taking 1 by x duration and 1 by y duration, that means you perform the LCM, which is x into y, and the summation would be x plus y, and the reciprocal is going to be xy by x plus y. So this is the shortcut that's used for these kind of simple questions. 3 into 6 by 3 plus 6, which is nothing but 18 by 9, which is 2, which was the same answer we got here. So this is the shortcut that's used, basically 1 by x, 1 by y, x plus xy by x plus y. So this is the duration and this is the efficiency. Okay. So just wanted to show this shortcut, but it's not very relevant. What is more important is that you grasp the concept here. That is, the efficiency means every hour what's the amount of work being done. So I hope you liked this video. I would like you to comment in terms of the kind of questions that you want to see further. And if you have any queries about new batches, etc., do drop a message over here. Thank you.